Hi. Well, here we go. This is our final project of the year in TTED 4010, and for it, I wanted to share with you something that did not exist when we went into online learning. This project only became available on April 2nd, and the people at Vex Robotics have worked really hard to bring this online to help all the kids and adults who are stuck at home doing homeschooling. And this is called VexCode VR, and the website is vr.vex.com. So it's a really cool way to introduce programming with a robotics twist to it. And as you know, I'm a pretty big fan of robotics. So let's take a look here. And if you go to vexrobotics.com, or if you just Google up VexCode VR, it'll probably take you to this page, and it talks to you a little bit about how things work. But what's really important is it's got a picture of the real robot that you would be using. This is a Vex IQ robot, and you can buy these kits relatively inexpensively. There is an international Vex IQ competition that takes place, and these are used educationally in thousands of schools and classrooms around the world. They're a really neat solution for teaching Vex, usually more at the senior elementary and middle school type level rather than the high school level, but they're perfectly fine at the high school and college level as an introductory machine. What's really cool about VexCode VR is that you can learn a lot of the things that you would need in the past to have had a robot in order to do, and you can do it right on your computer. So just before we get into the program, here's a couple things about the little robot that we're looking at. It is a tank drive robot. So you can see that the wheels are on fixed axles. So it is going to turn by spinning these wheels forward and those wheels backwards, or vice versa. So you can move forwards, backwards, and you can pivot about on your axis. And you can see your axis runs right down here. And this has a pen running right through the axis. And that pen can be raised or lowered so that you're going to be able to draw a line so that you can track where your robot's gone. And that can be a really useful troubleshooting tool, especially since in the VexCode VR, they've added a special little tweak that would be hard to do with this robot. And you can actually change the color of the pen as your robot drives along. So pretty cool what you can do right there. Now, what makes a robot instead of just a radio controlled car is it's got some form of sensors for feedback. And right up here, you've got a distance sensor or rangefinder, and that's going to look out from the front of the robot and a fairly narrow field of view, but definitely not just a point straight laser line. It looks out, and when it looks out there, it is measuring the distance to the nearest object. So that's all it's got. We've kind of got a minutar, the one eye thing. Cyclops. That's what I'm looking for. Getting my mythical beasts all mixed up. We've kind of got a Cyclops type thing where you've only got the one eye right here. And what makes it even trickier is you can't tell exactly what you're looking at. You just know that there's something there and how far away it is. Then we've got a couple of other sensors that can help us determine what's going on. This is a bump sensor right here. So when you bump into something, that can detect that you are pushing something with that side of the robot. And if you bump into something right here, that will push a switch in, and the brain of your robot can pick up and say, hey, something's pushing on this sensor right here. So you can tell when the left or right side of your robot has collided with something. And right down underneath here, we have a little color sensor that looks downwards, and you can use that to determine whether or not you are over top of an object of a specific color. Now that's useful for doing things like making sure you don't drive off the edge of a table. If you've got a red boundary around the table, you just say stop when I'm over the red. Might help you keep from going off the edge if you use it right. But the other thing that can do is it can also be turned to look forward, so you can have a forward eye or a downwards looking eye right in that position, and you can pick up the color of what you're looking at. So that's our robot, and it's a pretty cool little robot. And if we pop over here, this is how we program our robot. Now, if you've used Scratch before or any block-based programming language, this is going to look pretty familiar. You drag and drop the little block locks into place, and then you put the things that you want inside the little spaces, and everything has to fit together. So they'll either have little tabs and sockets that slot together, or they'll have round corners, or they'll have angled corners. And so you've got to put round things into round holes and angled corners into angle holes. But fairly common concepts right there. Now, what's really cool over here is if you click on the playground, then the playground comes up and you can choose from a whole bunch of playgrounds. And the default one is just a simple grid map that lets you drive your robot around, and it actually has a border on the field. You can look at the robot from a couple of different points of view. I always like to expand the window right here so I can see what's going on. And you can look at the robot from this point of view, and you can zoom around. You can see this one has a wall up, so your robot's not likely to fall off the edge of the field. That's pretty common for robot competitions, and it actually allows you to center your robot a little bit, because if you drive up against the wall, you can drive until both of your push sensors have touched and let you know that you're at the edge of the wall, and then you know that your robot's probably square to the edge of the wall if they're both touching. So you can take a look at that from a top view or from a more of a perspective view. Along the top right here, you've got information about your robot in real time. Well, obviously we're not traveling anywhere right now, but you've got the heading and the rotation and what your front eye is seeing. Right now it's not seeing anything. We're over top of white. When you're looking out to the front, there's nothing right in front of you. Looking down, there's nothing underneath you. You've got your location on the grid. 0, 0 of the grid is right at the middle of the grid. And so you've got a 2 meter by 2 meter grid. Everything in this quadrant is negative x and negative y. Everything in this quadrant is negative x, positive y. Over here, positive x, positive y. Basically, like a piece of graph paper that you'd have in math class, which is a nice tie-in for anybody working with students at the high school level where they're learning about graphing and math. And right here, your rangefinder is telling you how far it is to the nearest thing that it can see. And so it's measuring out this way. And from our little rangefinder right there to the wall, it's telling us it's 1.845 meters, 1845 millimeters. So that's some of the information that you can see. And there's a whole bunch of cool different things that you can get your robot to do. And for instance, there's the wall maze. So if you want to program your robot to go through a maze, there's some different challenges on the Vex site that you can say, well, okay, your challenge is to go through the maze and to stop on every letter or to stop on every color. So you can have the robot track that around and have it eventually come through here. Now, one of the things about the maze and with some of the other challenges is that it's always the same when you start up. So if you take a look at the dynamic wall maze, you'll see that it's always different. So this is really cool. They have code built in here that each time you come and put your robot onto the maze, the start position and the end position are going to be the same, but the maze itself is going to be different. So you can come in here and you can regenerate that, and now you've got a new maze. So your robot actually has to respond to the sensors to find its way through the maze. That is actually a really cool programming challenge, and we don't have quite enough time to do that one justice. So we are going to take a look at a different program. We're going to take a look at the dynamic castle crasher. Now, just before we go there, I did a castle crasher project with my students earlier and challenged them to come up with a faster castle crashing time than I did, and darned if a couple of them didn't beat me. So I'm just going to run through. Not going to show off their code, I'm going to show off my code, but I'm mainly doing this so I can show you how we can save and load our files. So right here in the file menu, notice you didn't have to have an account to log in. So unlike Scratch, Anybody can come in and use this. You don't need to set up a file. You don't save things to the cloud. You save them right to your computer. And when it comes time to load your file, you load from your device. You just click in right there. And let's see, right in here, we can come in here and I have saved my code into my downloads folder. And let me just take a look right here. There's my downloads. Oh, I think this is me. I should have changed the name right on here. Let's pop this up. And this is my code with all the nice little colors on here. And let's take a look at what it's going to do right now. Oh, I need to make a quick change. Put my stupid stuff back in here. Now what you can see is you can build your own blocks. So right there, stupid stuff is defined as this set of instructions that runs right down here. You can see I've added some comment codes in here so we can follow through what we're going to do. And as we go through here and as this code runs, watch how each of these blocks lights up. It'll start right here, and then as the robot goes through here, we come right in there, and you can see that I'm executing that code right there as I go through and do these various steps to try and clear all of the blocks off of the tower. Okay, there we go. This isn't my code. This is somebody else's code. What's going on right here? No, this is my. Anyway, it's executing this in a slightly different routine than I expected. Oh, this is my older code. It's not my best code. Okay, anyways, it's coming through right here, and you'll notice that we went through, and the very first steps were stupid stuff because it was just knocking things off. It was all pre-programmed, one step after the other, and it wasn't being very clever. It wasn't using a scanner, and it wasn't going around, and it wasn't looking for things. So here, the robot is now turning around, and you can see it keeps turning, and it's using our sensors in here, our rangefinder, and it'll keep turning until that range drops below 3000, and then it'll go and drive things off. And then it's using the bumper sensors and the front eye to detect to see if there's an object actually in front of it, because you can't always 100% perfectly rely on your sensors. They're actually pretty normal sensors that way. Just as you can't always trust your eyes 100%, you can't always trust the robot's eyes either. So here we go. It's moving around. It's actively hunting these blocks. When one of them slips or goes underneath it, it changes things up. And you can change your view on here to watch the little robot go out and do its thing. And it's like, oh, I missed that block. Picks that one up and off to the edge with it. Okay, and we come back over here and go little robot. Okay, so we're watching from the top here as that goes around to clear things out right there. Now, if you decide, hey, enough of that, you can always stop it and you can reset it, and all sorts of things that you can do. But there, oh, almost got that last one off. Almost got, there we go. We got that one off right there. Okay, now that's what that robot does. But the challenge with the Castle Crasher level when you're assigning it to your students is that you can do a lot of that just based on brute programming. You don't actually have to use your sensor. In fact, the fastest solution to clearing the Castle Crasher level that I've seen did not involve any use of sensors. One of the students had figured out how to get her robot to just go around and knock over every tower one after the other, and devastatingly efficient routine that completely cleared away my brilliant and clever answer. Obviously wasn't that brilliant and clever. So let's take a look right here. Dynamic Castle Crasher is a little bit different. So when I start it up right in here, you can see that the position changes each time you run this code. So your robot needs to be able to dynamically change and respond to what's going on in there. Well, let's take a look at how we might be able to get a robot to respond to that and do something useful. So I'm going to come over here to File, and I am just going to clear this all out, New Blocks Project, and I'm not going to save that. Now make sure that when you make your own file, before you navigate away from this website, that you save that file. That's really important, but I'm going to discard this right now. Start with an empty block right here. Now let's just start with a few of the basic commands right in here. We've got drive forward. And that's going to do exactly what you think it'll do. Go ahead and run a drive forward, and boom, we knocked that one over. You've really got to watch out for that little disc, and whoops, off of the edge. Well, why did we go off the edge? Because we didn't tell it to stop. The robots are not particularly clever. They do exactly what you tell them to do, not what you want them to do. So you might instead want your robot to drive forward, but not for 200 millimeters. Let's make it drive forward for 1500 millimeters. And now you can go ahead and you can tell it to start. And there goes our little robot. And you can see our green flashing light on there. That one keeps going until we get there. And we didn't hit that one quite hard enough to knock it over. Like I say, you got to watch this tower. It's got a little flat piece right in here that if it falls down the wrong way, it's too short to get caught and identified by your rangefinder, and it's flat enough that your robot will drive over it instead of pushing it. So that piece right there could be a little bit of a tricky one for your poor little robot. But here we go. It drives forward for 1500 millimeters and then stops. Okay, end of program right there. So let's take a look at some of the other things that we can put in here to make this work a little bit better. So we've got drive speed. So you can set your drive velocity in here. Well, we were only driving at 50% speed. You can bump that up to 100%, and you can also set your drive velocity up to 100%. Now, why do they not drive at 100% all the time? Well, for the exact same reason that you don't drive your car at 100% speed all of the time, or turn your car at 100% of your maximum turn radius all the time, is because if you're driving at 100% speed, by the time your little sensor sees that red mark right here to tell you to not go off the edge, you're probably going too fast, you hit the brakes, and you drive off the edge. But let's see what happens right here if we drive at full speed. And what we're going to do is we're going to make it drive right up to the edge. Now, that means we want to drive while we're over top of white. So what we're going to do is we're going to come down here and we can say while, okay, and then you've got your if sensors down right here. And we're going to come down here. Where are we here? While we want our condition to be met, we want our down eye. There we go. So you can drag one of these in here while our front eye, now I know it says front eye, but our down eye detects nothing. Okay, or white. So when we start off, that robot's going to keep going because it's just going to see white when we're not over top of anything. Then what we want to do is we want to drive. Now, those of you who've done a little bit of programming are saying, well, that's really great, but you still got a problem because we've only told the robot to drive forward. You also have to remember to tell it when that condition is no longer met to stop driving. So here we go. We are going to drive forward. Notice we're going faster now. Look at, we're hitting all those blocks. And wow, we managed to stop before we went off the edge. Sometimes, depending on how much other processing is going on in your robot, you can come to the edge of the table right there, and your robot's just a little slow to respond. And if you're going at 100% speed, you might be over that edge and gone off the table before your robot has a chance to respond. And once you're gone off the table, you're gone and you have to restart all over again. So there we go. That gets your robot going forward, and it'll go until it hits the edge. Now, maybe you want to do a little bit more than that because we certainly didn't hit anything right in there. So we want to do something more complex than just drive forward. So we want to turn until we're pointing at an object. So you can pull this drive forward right out of here. And what you can come in here is you can add another while statement in here. And of course, there's all sorts of other types of statements that you can add. But what we want to do is we want to get the robot to turn. So we can say while our let's see, distance in millimeters is what we use for measuring our rangefinder. So you can come in here and there's a greater than option right in here. So you bring your green in here and then you can say while the rangefinder is greater, distance in millimeters is greater than, we want to do this until we can see something. The longest range we'll ever see anything at is 2000 because that's from one side of the board to the other. So while we don't see anything, our default range, if we don't see anything, is 3000, while our distance in rangefinder, the next object, is greater than 2000. We're just going to have it turn right. Or you could make it turn left, it doesn't matter. So it's going to keep doing this until this condition is no longer met. So if it sees something, then what you're going to do is you are then going to drive forward. There we go. Let's see what happens. There you go. You can see it pulsing back and forth in there. And it takes a turn right there and comes around, knocks things off right there. And now it comes to the edge of the table and it has stopped driving because we're over top of the red edge of the table. Well, that's a little bit of a problem and you're going to have to figure out what you want to do right there. And you've got to be a little bit careful because you never know which direction you're going to be facing when you come to that edge. And if you just tell it to back up, sometimes it'll back up right off the edge of the table. So there's some other really neat things that you can do in here to help your robot figure out what's going on right here. So one of the things that I like to do is use the print statements right here. And so when you're trying to track how your program runs, you can say in here, print turning. And then when you're down here, you can say driving. So now when you run your program, you can come in here, reset that, start it up again, and you click on this little button right here. And this brings forward a diagnostic window that you can use to track your sensors, track variables, and right down here, you've got an output screen, just as you would with your serial monitor on the Arduino, where all your printed data is going to come out in here. It's driving, 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 driving. And now, I just meant to stop that or pause it. And right in here, well, we've just got this big line going off the edge of the screen. In order to make that a little easier to read, you probably want to then set your cursor to the next row so that you can have that print out one at a time. Set cursor to next row. Right in there. Let's try that again and watch our results. There we go. I've got to remember to not hit the reset button. I've just got to hit the stop button in here. And look at that. We went out and we found things. And now you can see what your program's doing. We were driving, 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 and we were turning, turning, turning. And you can also use that to print out sensor status and get a log file of what your machine is doing, which can be really helpful. If you've got multiple drive statements in your program and you want to track what's going on and you need a little bit of help with that, so say we start off just by having it drive forward for, let's just come right up in here and say I want to start by going to the middle of the screen. You can have it drive forward for 1000 millimeters. But what you can also do in here is you can come in here and you can set your pen color. So this drive statement drives with a black pen. And where's my set pen color? Right down here. This drive statement will drive with a green pen. We'll reset that and watch it go. And now we're not getting anything coming off there. What's going on right there? Set drive. Oh, I guess I need to set the pen down. Where did my pen down go? There's a pen down command right in here. Move robot pen down. That's going to make that pen work a whole lot better. And so if you've got your pen down and some different colors on here, you can see you start off driving in black, and then once you switch into your autonomous routine, you can put it into green. And gosh, now you can see that we're hung up on that edge in red again right now because we detected red color. That broke us out of this loop right here and set us to the stop driving. And there's no loop surrounding that. It doesn't know what to do when it's over top of red. Now, obviously, there's solutions to that, but if I went and covered all that, I'd be making it no fun for anybody. Some other things that you can do in here. Maybe you only want your robot to operate for 60 seconds. So your challenge is to knock as many towers as possible over in 60 seconds. Okay, so what we can do in here is we can take this little segment right here and we can, I'll put variables in there. You can put it inside a loop. So let's add something in right here. We will take our timer, and in our main loop, we'll start by resetting the timer right here at the beginning of the program. And don't go burying that into your main loop where we're doing our tests. And what we'll do is we'll do this while, and then we'll use an AND statement. So drag our down I out of here, and we can put an AND in right here. And we can say then while, keep doing it while our timer in seconds is less than, keep that in there, is less than 60. So now our guy will keep on going in here for 1 minute. And when you come back here, if you're over 1 minute, it will automatically stop and kick you out to the stop driving here. So you can actually have some limits on how much you can do on your board. So let's see right here. We'll just let that run in the background, see if it manages to keep going for 1 minute. And nope, we're over top of red. So we've got a problem on there because we've got this stop driving right in there. You need to find a way to get yourself off of the red right there. Now, testing for red is maybe not always the best way that you're going to be able to detect things on here. Remember that you've got XY coordinates that you can also test for. So if you want to slow down as you get close to the edge, you can use your XY coordinates to say, hey, I'm getting close to the edge, I should slow down, or maybe I should turn gradually to come back in. Depends on how you want to structure your algorithm. You have to figure that out and make it work the way you want it to work. Let's see, we've got the edges right there. You've got your XY coordinates. Because you've got your XY coordinates, it also lets you do some really neat stuff with trigonometry because obviously you've got a computer in here. You can do math and you've got variables right in here. So you can bring in, you can have an absolute value. You can have floor and ceiling, so you can take a look at the highest value, square root, and of course, here's your trig function, sine, cosine, tangent, arcsine, arctangent. You can even get into logarithms and natural logarithms in here. Don't know as they're going to be directly applicable, but boy, I've sure found some of those trig functions useful for figuring out where my robot is and how to get it pointing towards center, get it pointing towards a certain position. Well, there we go. Absolutely awesome, engaging program. all sorts of fun games to play on it, ways to challenge your students. And if you start looking around, there are going to be more and more tutorials building up over the next little while. This is an awesome project that's come along. April 2nd, 2020, it launched, and they've been improving it every week since then. I'm really impressed with what Vex has been doing with VexCode VR, and I wish them a lot of success in the future. If you've had a positive experience with VexCode VR, or maybe you ran into a bug or a glitch or something like that, give them a bit of feedback right there. They've got the feedback form right on their page, and give them a happy face. They're always happy to get that because they're working hard to make this better for you. Tell them what you like. If you've got a wish list for things, include it in there. And if you pop your email in, maybe they'll even send information back to you. So there we go. It's an awesome little program. It's an awesome way to start and have fun clearing the dynamic castle crasher level.